Welcome to the Deep Dive. Today we're diving headfirst into a topic that's quickly moving beyond simple automation and even beyond the generative AI we've all been hearing so much about. We're talking about agentic AI. It's a technological leap that seems to be paving the way for truly, well, autonomous enterprise operations. So our mission for this deep dive is really to unpack exactly what agentic AI is. We want to understand how these intelligent systems actually work and explore their often surprising applications across different industries. We'll also examine the dynamic market shaping this evolution, dig into its profound economic and organizational impacts, and, maybe most critically, confront the significant risks we all need to understand. Think of it as your shortcut to being well-informed of what might just be the next big thing in AI.
Absolutely. And what's truly fascinating here, and what our sources really emphasize, is that the core idea behind agentic AI represents, well, a fundamental shift. We're moving from thinking about AI as a tool, something we prompt to generate some content, to AI as a teammate. Imagine a digital worker that's capable of independent, goal-driven action. This isn't just an incremental improvement. It feels like a profound redefinition of how technology can operate within our businesses, maybe even our lives.
Okay, let's unpack this. When you say digital worker and independent action, that sounds very different from my experience with, say, a chatbot. What exactly is agentic AI, and how is it fundamentally different from the generative AI we've become so familiar with lately?
Right. At its heart, agentic AI is defined by its capacity for autonomy, for goal-driven behavior, and, crucially, adaptability. Unlike a traditional program that just follows a fixed set of rules, these systems aren't merely following a predefined script. They're actually designed to make decisions in dynamic environments, often with pretty minimal human intervention, all to fulfill some high-level objectives. This proactive nature, their ability to act purposefully and independently, well, that's what gives them their agency.
That's a powerful distinction. So it's not just responding to prompts, it's actually taking initiative. Can you give us a more concrete picture of how they operate? What are these cognitive functions you mentioned that allow them to do this?
Absolutely. Think of it as a continuous, sort of cyclical process. It remarkably mimics human cognitive functions in a way. It starts with perception. This is where the agent gathers multimodal data from all sorts of sources, user interactions, internal databases, external APIs, maybe even real-time sensors. It could be text, images, audio, sensor readings, really anything. This constant data stream ensures the agent has an up-to-date understanding of its context.
So it's constantly observing, like a very diligent student, always gathering new information. Okay, what's the next step in its learning process?
Exactly. After perception comes reasoning and goal setting. This part is often powered by a large language model, acting as the brain or maybe the orchestrator. The agent processes the data it perceived, and based on a high-level goal that you provide, it uses advanced reasoning techniques, things like chain of thought.
Ah, I've heard of that.
Right, which is essentially breaking down a complex problem into smaller sequential steps, much like we humans do. It breaks down that big objective into manageable subtasks. Then comes planning. With those subtasks defined, the agent formulates a strategic plan. It evaluates multiple potential paths and actions against factors like efficiency, accuracy, and, predicted outcomes. After planning, it moves to execution, and this is a really crucial differentiator from standard generative AI. The agent acts on its plan. It might execute code, call external tools via APIs, maybe book a flight, query a stock price, interact with a customer database, or even communicate with other AIs or humans.
Okay, so it's actually doing things.
Precisely. And finally, there's learning and adaptation. After executing an action, the agent observes the outcome and gathers feedback, often through something called reinforcement learning. This lets it evaluate how successful its actions were and refine its strategies over time. It improves its performance without needing explicit reprogramming for every single new scenario. It genuinely learns from experience.
Wow, so it's not just generating text or an image. It's doing things in the real world, iterating, getting better. That's a huge leap. Okay, here's where it gets really interesting for me. How does this compare to what we already have? Like robotic process automation, or even the generative AI that's everywhere now? I can almost hear listeners thinking, isn't this just, more sophisticated automation?
That's a great question, and it's really important to clearly distinguish agentic AI from what came before. Take robotic process automation, RPA. RPA bots are, deterministic and rigid. They follow a predefined script for very structured, repetitive tasks, like copying data from spreadsheet A to spreadsheet B. If the user interface changes even slightly, or if the data is unstructured, RPA often just fails. Agentic AI, on the other hand, is designed for dynamic environments. It can process unstructured data, adapt its actions based on context, and handle really complex end-to-end workflows that are way beyond RPA's reach. It's about adaptive problem solving, not just blindly following rules.
Okay, that makes sense for RPA. What about the comparison to generative AI?
Right. The distinction from generative AI is maybe more nuanced, but it's critical. Generative AI primarily creates content.
Mm.
It responds to your prompt by generating text, images, maybe some code. So a large language model can write you a fantastic, detailed travel itinerary listing flights and hotels. But an agentic AI acts on that information. It uses an LLM as its reasoning engine, sure, but then it plans and executes a sequence of actions to achieve a real-world goal. So while the LLM writes the itinerary, the agentic system would actually take that itinerary and autonomously book the flights, reserve the hotels, maybe even make the dinner reservations. It turns the output into action.
That distinction between generating an itinerary and actually booking the trip, that really crystallizes the concept for me. That's powerful. And I know the sources talk about a spectrum of autonomy. How far can these agents really go on their own? Can you walk us through those different levels?
Yes, exactly. Agency isn't a simple on-off switch. It's more of a gradient, a spectrum that we need to calibrate carefully. We can sort of frame it in 4 levels. Level 1, or chain, is basically rule-based automation, very much like RPA, where both the actions and their sequence are predefined. Pretty straightforward. Then, at level 2, workflow, the specific actions are still predefined, but a large language model dynamically determines the optimal sequence of those actions based on the situation.
Getting smarter.
Right. Then there's level 3, partially autonomous. Here, you give it a high-level goal, and the agent can plan and execute a sequence of actions using a specific set of tools, but with minimal human oversight. This is where we start seeing true independent decision-making emerging. And finally, level 4, fully autonomous. This means the agent operates with little to no human oversight. It can proactively set its own sub-goals and might even create or learn to use its own tools to achieve the main objective.
Wow. Where are we mostly seeing applications today?
Currently, most enterprise deployments are hovering around levels 1 and 2, maybe dipping their toes into level 3 in certain specific controlled domains. Level 4 is still largely experimental, and a critical development that's pushing this further is the rise of multi-agent systems.
Ah, okay, what's that?
This involves creating a collaborative ecosystem of specialized AI agents that work together, much like a human team. So, for example, you might have a high-level supervisor agent that breaks down a big goal, like launch a new marketing campaign. It then delegates specific subtasks, maybe to a research agent to gather market data, a creative agent for ad copy and visuals, and a media buying agent to actually execute the campaign across different platforms.
Yeah.
This mirrors how human teams work and allows for solving really complex, multifaceted problems.
That's a great analogy, the supervisor and the team of specialized agents. So it's a team effort, not just one super powerful brain. This also makes me think about calibrating risk, which you mentioned.
Exactly. It's absolutely crucial to understand that agency is a spectrum that has to be calibrated very carefully. The level of independence you grant an agent must match the task's risk profile. You might give pretty high autonomy to an agent generating, say, internal marketing content. But a financial trading agent, that would require extremely stringent human oversight, perhaps even a human-in-the-loop approval for every single trade. The whole idea of set it and forget it with agentic AI is, frankly, a dangerous myth. It's really a dynamic partnership that requires continuous human judgment and very careful oversight.
That's a vital point to remember. So we've seen how these agents think and act, really moving beyond simple automation. But where are they actually showing up today? What are some of the most maybe surprising ways companies are putting this new digital workforce to work?
The practical applications are genuinely transformative. They're shifting companies from just optimizing little discrete tasks to achieving much more holistic business outcomes. Let's start with business operations and workflow management. In human resources, for example, agents can proactively source candidates from diverse platforms, conduct initial conversational screenings. They can even identify internal employees who might have untapped skills suitable for new roles. For onboarding, they can handle provisioning system access and act as a sort of 247 resource for new hires. IBM, for instance, has a system that reportedly predicts employee attrition with something like 95% accuracy, allowing HR teams to step in proactively.
95%. Wow. That's impressive. What about other areas like finance or IT?
In finance, agentic AI enables continuous risk monitoring of transactions in real time, flagging anomalies and potential policy violations literally as they happen. Forecasting agents can synthesize vast streams of data to autonomously update financial forecasts and even suggest course corrections if variances pop up. For IT operations, imagine an employee has a Wi-Fi issue. An agent could handle it start to finish. Gather details, run diagnostics, attempt fixes like updating drivers, and only escalate to a human technician if it can't solve it, providing a detailed, pre-analyzed report.
So it's not just an advanced chatbot for IT, it's literally doing the troubleshooting. That's a huge shift from a human having to collect all that information manually.
What about industries with more of a physical component, like logistics? Indeed. Moving into the physical world, logistics and supply chain management is a huge domain for this. For proactive inventory management, agentic systems continuously monitor stock levels. But they also ingest external signals like market trends, news about geopolitical events, even real-time weather forecasts to generate dynamic demand predictions. Then they can autonomously trigger replenishment orders or reallocate stock across warehouses. Amazon's system, for instance, reportedly makes something like 35 million forecast updates per week. An AI-driven inventory optimization can potentially reduce costs by 20–50% for businesses.
That's a staggering number of updates.
It is, and this extends to dynamic route and load optimization. Agents analyze real-time traffic, weather, port congestion, all sorts of data, to continuously calculate the most efficient routes for delivery fleets. This can lead to up to 30% cost reduction and maybe 25% reduction in transit times. For autonomous procurement and vendor management, agents can monitor supplier performance, analyze contract terms, and even autonomously negotiate for the best rates, balancing cost, speed, and reliability factors.
And handling disruptions, that seems like a key area.
Absolutely. In the face of disruption, agentic systems can truly shine. For disruption response, say a factory shuts down unexpectedly or there's a natural disaster, an agent can detect the disruption almost instantly, identify all the affected shipments, and then execute a multi-part recovery plan, finding alternatives, rerouting vehicles, reallocating inventory potentially, all within minutes. Siemens, for instance, uses agentic AI for predictive maintenance in its factories, and they've reported a 25% reduction in unplanned downtime because of it.
That's incredible, going from a very manual, often slow reactive process to a proactive, automated response in a crisis. It really highlights the speed and scale that humans just can't achieve alone.
Yeah.
You also mentioned automated deals. How did that work? Sounds intriguing.
Right. Another fascinating area is how it's transforming the art of the automated deal, particularly in negotiation and contract management. For automated contract analysis, agents can ingest entire portfolios of contracts in seconds, rapidly extracting key clauses, identifying potential risks, analyzing terms. This frees up legal professionals for higher-level strategy instead of tedious review. Agents can also assist in negotiation strategy formulation. They process market data, historical outcomes, competitor actions to suggest optimal negotiation approaches. And they can provide real-time negotiation support, offering instant analysis and even counter-offer suggestions during a live negotiation. Some companies, like Pactum, are already using Agent for fully autonomous negotiations, typically for high-volume, lower-value agreements.
Fully autonomous negotiations, that's quite something.
It is, and the real power, as our sources suggest, lies in orchestrating an end-to-end workflow using these multi-agent systems we talked about. Imagine a customer billing dispute. A CRM agent confirms the customer's identity, a billing agent cross-references the data, finds the error, and a dispute resolution agent automatically corrects the charge and notifies the customer, all happening autonomously, seamlessly. Key players like LegalFlyY, Syrian, Icertis are building platforms aiming for these kinds of capabilities. The most impactful applications really create a kind of nervous system for the enterprise, tying together diverse data streams to achieve these holistic business outcomes, not just optimizing isolated tasks. But this absolutely requires a robust, integrated data infrastructure underneath it all.
That's genuinely fascinating. It's clear these aren't just theoretical concepts anymore. They're already delivering tangible, real-world value. So let's talk about the ecosystem that's supporting all of this. Who are the companies and what are the technologies leading this charge in the market, from the foundation layer right up to the applications?
Okay, yeah, the market is definitely dynamic and it's rapidly stratifying into distinct layers. At the base, you have the foundational platforms and infrastructure. Let's call them the titans.
Yeah.
These are the major cloud providers and the big hardware players. In cloud and AI platform providers, you see Microsoft, obviously, with its Azure AI Foundry and that deep OpenAI partnership, integrating agentic capabilities across products like Microsoft 365 Copilot. Then there's Amazon with AWS Bedrock and its Strands Agents SDK, really enabling agent development within secure environments. Google, through Vertex AI and its Gemini models, is pushing quite advanced agentic systems with built-in memory and tool use capabilities. And you also have IBM with Watsonx focusing particularly on trusted, governable agentic AI, especially for regulated industries.
And hardware. I assume NVIDIA plays a big role.
Absolutely. For hardware and enablers, NVIDIA is just foundational. Their GPUs, their CUDA software platform, things like their NIM agent blueprints, they're essential for training and running these large-scale AI models. They're critical for almost every other player in the space, really.
Okay, so that's the foundation. What about the next layer up, the applications?
Right. Above this infrastructure, we have the application layer, which is buzzing with specialized vendors and startups. You have the enterprise workflow leaders like Salesforce embedding agentic AI into their Einstein Copilot and something called Agentforce to automate sales, service, marketing operations, the core CRM stuff. ServiceNow is building domain-specific agents within its Now platform, envisioning teams of agents collaborating across different functions like IT, HR, finance. And SAP is extending its AI assistant, Joule, aiming for it to act as a universal agent across complex ERP processes.
So the big enterprise players are definitely involved. What about more specialized areas?
Exactly. In procurement and supply chain specialists, you see companies like Coupa, Zacus, and Zip offering multi-agent suites for the whole source-to-pay lifecycle, while logistics firms like Blue Yonder, Kinaxis, and Fourkites are deploying agents specifically for inventory operations and that disruption response we talked about. And then, of course, there are the emerging startups tackling very specific problems. You mentioned Acefa AI automating pharmacy operations, Cognition Labs with their Devon, the AI software engineer concept, and Pactum, which, as we said, focuses squarely on autonomous commercial negotiations.
It's incredible how quickly these specialized applications are popping up, but I also know there's a really strong open source movement in AI generally. How does that fit into this agentic landscape? Is it playing a role?
Oh, absolutely. Parallel to the commercial market, there's a very robust open source movement that's significantly lowering the barrier to entry for building these things. Key frameworks like LangChain provide these modular toolkits for building LLM-powered applications. It acts almost like an operating system for agents. AutoGen, which came out of Microsoft Research, is designed specifically for orchestrating multi-agent conversations, allowing agents with different roles to collaborate effectively. Crew AI is another one, focusing on collaborative role-playing agents, enabling you to set up teams for tasks like financial analysis or complex research projects.
So what's the impact of this open source activity?
It's huge. It lowers barriers to entry, obviously, fostering a much wider community of developers and researchers. It also offers organizations greater control, more customization options, and critically enhanced data privacy because you can often host these open source models and frameworks on your own premises.
So, okay, what does this all mean for companies looking to actually get involved? It sounds like there are a lot of ways to approach this, from buying something off the shelf to building something completely custom using these tools.
You're absolutely right. Enterprise leaders face this kind of build versus buy versus assemble choice. You can build a highly customized solution, maybe using foundational tools or open source frameworks. This offers the most differentiation, but it requires significant in-house expertise and resources. You can buy a pre-built, more turnkey solution from a vendor. This usually means faster time to market, but probably less customization and potentially vendor lock-in. Or you can try to assemble a solution, maybe using open source frameworks combined with proprietary data and some specialized vendor tools. This tries to balance flexibility and speed. The right strategy really depends entirely on your specific use case, your company's technical maturity, and honestly, the strategic importance of the workflow you're trying to automate or augment.
So no single right answer.
No, definitely not. But what's becoming clear, according to our sources, is that the key differentiator in this market is shifting. It's not just about having the most intelligent brain, the best LLM. It's increasingly about the sophistication of the orchestration capabilities. The real challenge, the hard part, is building that robust nervous system we talked about. The system that allows agents to reliably plan complex tasks, use external tools effectively, manage memory across long-running interactions, gracefully handle errors when things go wrong, and collaborate effectively with other agents and existing systems. Mastering that agent coordination piece, that's likely what will define the long-term winners in this space.
This is truly fascinating stuff, and it really sounds like it will fundamentally change how we work and how businesses operate. What's the broader impact we can expect? Thinking about the economy, about organizations themselves, what's the potential productivity dividend here?
The economic potential, often framed as that productivity dividend, is potentially staggering. While generative AI alone was projected by folks like McKinsey to add trillions annually to the global economy, agentic AI is really poised to significantly amplify that value by making Gen AI actionable. It drives value from several key sources. First, just a dramatic acceleration of execution. You eliminate human handoffs, you compress complex cycle times from days or weeks down to potentially mere minutes. Second, obviously, enhanced efficiency and cost reduction through automating these end-to-end workflows. We heard examples like DHL reporting 15% operational cost reductions, Siemens maybe 20% of maintenance, and logistics seeing those 20–50% of inventory cost reductions. Those are a significant number.
Absolutely. Is it just about cost savings, though?
No, not at all. Beyond savings, agentic AI is expected to power significant top-line growth. It enables hyper-personalization at a scale we've never seen before, allowing companies to offer truly tailored products and services down to the individual customer level. It can also create entirely new revenue streams. Think about embedding agents directly into products to unlock premium features, or even offering specialized AI agents as a valuable software-as-a-service product itself. You have analysts like Goldman Sachs Research projecting the software market could expand by at least 20% more than previously forecasted, specifically because of agents, with that agent component potentially accounting for over 60% of the total software market by 2030. And Gartner forecasts that 15% of all daily work decisions could be made autonomously by AI agents as soon as 2028.
15% by 2028. That's not far away. This sounds like it will fundamentally change how we work our day-to-day jobs. How will it reshape roles?
It absolutely will. The future of work involves a pretty fundamental redefinition of human roles. As agents take over more complex but ultimately procedural workflows, the focus for human workers is going to shift. It shifts away from doing the step-by-step work towards defining the goals, delegating the tasks to AI agents, and then supervising the outcomes. This really elevates uniquely human skills: strategic thinking, creative problem-solving, complex relationship building, ethical judgment, things where humans still hold a significant edge and can complement AI.
So it changes the skills that are most valuable.
Exactly. And the skill shift will likely lead to significant organizational restructuring. Companies might move toward flatter, more agile, more outcome-oriented structures. The focus shifts from who owns the specific task to what overall outcome are we trying to optimize for. Something like 81% of business leaders, according to surveys, expect this kind of structural transformation. This obviously necessitates a massive upskilling imperative. The workforce simply has to be retrained for this new reality of human-agent collaboration. Surveys show 86% of people value this skill. It also requires a whole new managerial mindset, learning how to effectively manage AI coworkers. How do you articulate tasks clearly for an AI? How do you delegate effectively? How do you supervise and validate the results? About 84% of leaders say they plan specific AI training for their employees.
Managing AI coworkers, that's a new one.
It is. And there's also a potential downside, a risk of polarization in the labor market. Mid-level knowledge work, the kind that's complex but follows certain patterns, seems most susceptible to automation. This could potentially hollow out the middle of the job market. Those who can effectively become AI-augmented strategists, leveraging these tools, will likely see their value increase significantly. The future really looks like a human-agent collaborative framework, a hybrid workforce. Humans provide the strategic direction, the ethical oversight, the empathy, the creative insight. Agents provide the speed, the scale, the data processing grunt work, and the execution power.
It's a partnership, that.
Ideally, yes. And it's interesting, research from Stanford University, using their human agency scale, has actually shown that workers often desire more human control over processes than might be strictly technologically necessary. This really underscores the critical need for human-centric design when we deploy these AI agents. We need to tailor autonomy levels not just to the task's risk, but also to human preferences and comfort levels. Ultimately, the sources suggest that organizational agility becomes the single most important competitive advantage in this new era. Being able to operate at the speed of data, not hampered by the speed of traditional org charts.
This is a lot to take in, and it sounds incredibly powerful, with truly massive implications for our careers and our companies. But with great power comes, well, you know the rest. What are the downsides? What are the significant challenges or risks we absolutely need to be aware of?
That's precisely the critical next step, and maybe the most important one. The very autonomy that makes these systems so powerful also, unfortunately, introduces entirely new vectors for failure and potential harm. Addressing these risks isn't just an optional extra, it's absolutely central to unlocking the technology's real value. Let's start with just technical reliability. LLMs, the core reasoning engine for many agents, are known to hallucinate. that is, generate confident-sounding but factually incorrect outputs. In an agentic system that acts on this flawed information, the consequences could be catastrophic. Imagine an erroneous stock trade based on a hallucination, or a flawed legal brief submitted automatically.
Right, the stakes are much higher when it acts.
Exactly. We also face what some researchers call the complexity cliff. Even very advanced reasoning models can suffer a complete performance collapse when problems exceed a certain complexity threshold. And counterintuitively, they might just give up without communicating their uncertainty, or they might fail to follow explicit instructions correctly. Another tricky issue is non-determinism. Unlike traditional software, these agentic systems can produce different outputs or take different actions even for the exact same input. This is due to the probabilistic nature of the underlying LLMs. It makes validation, testing, and auditing incredibly difficult, especially in regulated industries where consistency is key. And then there's basic error handling and robustness. Agents absolutely must be able to gracefully handle failures and external tools they rely on. They need to know how to retry actions appropriately and, critically, how to escalate problems they can't solve to a human. Otherwise, they risk getting stuck in loops or just failing silently, which can be dangerous.
That complexity cliff sounds particularly worrying if an agent just silently gives up without warning. What about security? Does giving AI agents more autonomy automatically mean opening up more security risks?
Unfortunately, yes. Securing the autonomous agent introduces a whole new and quite challenging threat landscape. Agents are susceptible to existing attacks like prompt injection, where malicious instructions are snuck into their inputs, but the risk is significantly amplified because a hijacked agent can act on those instructions, maybe sending phishing emails to all your customers using your legitimate email system, or exfiltrating sensitive data by interacting with internal APIs.
So the attack surface expands.
Dramatically. And key agentic attack vectors are emerging. Things like memory poisoning, where an attacker subtly feeds false information into an agent's long-term memory over time to corrupt its future decisions and biases. Or tool misuse, which involves tricking agents into using their legitimate, authorized tools for malicious purposes, like getting a customer service agent to reset passwords inappropriately.
That sounds insidious.
It can be. And a huge enterprise risk is privilege compromise and shadow AI. This is where employees might deploy agents, perhaps using open source tools without proper IT oversight. These agents might then inherit excessive system permissions from the employee's account, making them incredibly high-value targets for attackers. If that agent gets compromised, the attacker gains significant access. And in those multi-agent systems we discussed, you have risks like cascading hallucinations, where one agent's error spreads rapidly through the connected system, leading to widespread failure. Or attackers could subtly manipulate an agent's high-level goals over time, hijacking it for nefarious purposes.
So how do we defend against these?
Mitigation strategies are still evolving, but they include things like network microsegmentation, basically isolating different parts of the network to limit the blast radius if one agent is compromised, and rigorously enforcing the principle of least privilege, making absolutely sure agents only have the bare minimum permissions they need to perform their specific tasks, and nothing more.
Those are serious technical and security concerns, especially that shadow AI risk where agents are deployed without proper oversight. This leads to the big question: who is ultimately responsible if something goes wrong? That brings us squarely to governance, right?
Exactly. Finally, and perhaps most fundamentally, we must address the governance imperative. This covers crucial areas like accountability, liability, and bias. When an autonomous system inevitably causes harm, maybe a significant financial loss due to a trading error or discrimination in an automated hiring process, who is actually responsible? Our traditional legal frameworks really struggle with this accountability gap. Is it the developer, the user, the company deploying it? It's often unclear. Then there's the persistent black box problem. The internal workings of many complex AI models are opaque, making it incredibly difficult to explain why an agent made a specific decision. This erodes trust and makes auditing, especially after an incident, extremely complicated. And algorithmic bias remains a huge concern. If the data used to train these agents reflects existing societal biases around race, gender, age, etc., the agents can easily perpetuate or even amplify that discrimination in their actions. Think about unfair loan processing or biased candidate screening. This can lead to seriously unethical and potentially illegal outcomes.
So what's the solution on the governance side?
It requires robust ethical frameworks and human oversight built in from the very beginning. This means implementing transparency measures, using explainability tools where possible, conducting regular bias audits of both data and agent behavior. It also requires meaningful human in the loop, where a human must approve critical actions or at least human on the loop oversight, where a human monitors and can intervene, especially for high stakes decisions. Ultimately, the central challenge tying all these risks together is trust. We saw that stat over 80% of companies reporting no material earnings yet from generative AI initiatives, largely due to hesitation and a lack of trust. Therefore, investments in building that trust through explainability, through bias auditing, through robust security, through human-centric governance are absolutely paramount. They're not costs. They're necessary investments to unlock the value. It creates this interesting paradox. Achieving greater autonomy out at the edges, where agents operate, actually requires stronger, more centralized governance at the core of the organization. Letting shadow AI run rampant is just a recipe for disaster. A central AI governance body, setting clear policies and standards, becomes essential to avoid chaos.
This has been an absolutely incredible journey through the complex world of agentic AI.
Yeah.
It's abundantly clear this isn't just some incremental evolution, but potentially a truly disruptive force that's set to reshape businesses and maybe work itself as we know it. So, wrapping this up, what does this all mean for you, our listener, whether you're leading an organization or just trying to navigate this rapidly changing world?
Right. For leaders, based on what we're seeing in the sources, there seem to be several key strategic imperatives emerging. First, develop a centralized agentic AI strategy and governance body. It's time to move beyond ad hoc experiments. You need a unified strategy with clear policies, ethical guardrails, and oversight across the entire organization. Second, invest in your foundational data and orchestration infrastructure. Agents are only as good as the data they access and the platform that coordinates them. Prioritize creating a clean, integrated data estate and selecting or building a robust orchestration platform that can handle multi-agent collaboration, tool use, and error handling reliably.
Okay, central strategy, solid
Wow.
foundation.
Yeah.
What else?
Third, adopt a governance by design and trust first mindset. Security, ethics, reliability, these cannot be afterthoughts. They must be built into the design from inception. That means planning for human-in-the-loop oversight where needed, demanding explainability features, proactively auditing for bias, and implementing zero-trust security principles from day one. Building trust, as we said, is probably the most critical investment you can make. Fourth, really start to reimagine work, roles, and talent development. Proactively begin redesigning organizational structures and career paths for this future hybrid human-AI workforce. A massive investment in upskilling and reskilling is simply non-negotiable. Focus on strategic thinking, creative problem solving, and developing those new managerial skills needed to effectively supervise a digital workforce.
And how should companies actually start rolling this out?
That leads to the final point. Pursue a phased rollout, starting with high-value, low-risk use cases. Please don't attempt a big bang implementation across the whole company at once. Begin with carefully selected pilot projects, maybe internal HR or IT support automation, areas where the potential for serious harm is relatively low, but the opportunity for learning and demonstrating value is high. Use the successes and the failures from these pilots to build internal expertise and gain buy-in before tackling more complex, mission-critical applications. Learn and iterate.
It really paints a picture of a future where human ingenuity isn't replaced, but potentially profoundly amplified by a scalable team of these intelligent, autonomous agents. It could lead to completely new eras of innovation and growth. The transition will definitely be complex, maybe bumpy, but it seems like it's happening, and perhaps happening faster than many anticipate. So as we close out this deep dive, here's a final thought for you to mull over. Given the immense potential, but also the very real inherent risks of agentic AI, what part of your own work or your own organization will you consider reimagining first? And perhaps more importantly, what ethical guardrail will you prioritize above all else as you start down that path?